Okay, this video is about rational exponents, and it's from chapter 7, section 4 in your book. So these two expressions that I have written here are the basis of the lesson. So the cube root and a square root, any kind of root actually, can be written as a rational exponent. And it's like this. A cube root is the same thing as 1/3. A square root is the same thing as 1/2. And let's solve these two separately. 125 is the same thing as 5 cubed. So I'm going to replace 125 with 5 cubed in each expression. Okay, now on the left side, if you remember from exponent rules that you multiply 3 times 1/3, and so you get 5 raised to the 1, because 3 times 1/3 is 1, and the cube root of 5 cubed is 5. We learned that in the last lesson. So these two expressions are equal to each other. Similarly, when you have the square root of 5 times the square root of 5, I could write that as 5 to the 1/2 times 5 to the 1/2. This exponent is signifying the same thing as this square root symbol is here. Okay, so square root of 5 times square root of 5 is the same thing as the square root of 5 times 5, which is equal to the square root of 25, which is equal to 5. 5 to the 1/2 times 5 to the 1/2, the base is the same in both of these, so we can add the exponents. So you get 5 to the 1/2 plus 1/2, which is equal to 5 to the 1, which is equal to 5. So these two expressions are equal, and you can solve them in whichever form you prefer. Okay, so in general, a raised to the m over n is the same thing as a raised to the m over n. So let's look at that. We had a 5 cubed, so let's do that. Let's say 5 to the 3 over 3 is equal to the cube root of 5 to the 3. This is what we saw in the first example, and let's do a more general expression. 5 to the 2/3 is equal to the cube root of 5 squared, because the denominator of the fraction is the index of the radical, and then the squared goes inside. Now also, this could be written as, this is also an equivalent expression. So sometimes it's easier to write that way, and I'll use this fact a few times. So let's do some examples of that. Okay, so x to the 1/3 is equal to the cube root of x. That's just a different way of saying what I did with numbers in the first place. It's also true with variables, because variables just represent numbers. So let's write x to the 3/5 as a radical. Okay, so you need the radical sign, and x is going to go inside. The denominator is the index, and the numerator goes inside the radical. Or you could write this as the 5th root of x, all of that cubed. These three expressions are equivalent. Okay, and if I had something like this, y raised to the negative 2.5, that's the same thing as y to the negative 5 over 2, which I could write as 2 times y to the negative 5. Or, this is when it's useful to write the negative on the outside, because when you have a negative exponent, that's the same thing as saying 1 over that. So this is equivalent to 1 over the square root. I don't have to write 2, but I'm writing it here just so you can see the pattern of y to the 5th. Or I could say it's 1 over the square root of y raised to the 5th power. These two expressions are equivalent, and that's the way that you would write this expression with a radical. I prefer this term, just you don't need to write that, so don't write 2. Okay, so since any radical can be written as an exponent, it's probably a good idea for you to review these properties of exponents. So you might want to pause the video now and review these properties if you need to. Okay, so let's use this in exponent form, and we're going to go ahead and solve this problem, simplify it, and then we'll rewrite it in radical form and solve it that way. So radical form, you'd have negative 32 on the inside, the denominator is the index, and then you have cubed on the outside. Alright, let's solve it in this form first. So negative 32 is the same thing as negative 2 to the 5th. And then we're going to raise that to 3/5, because 32 is the same thing as 2 to the 5th. Then over here, we can do the same thing. Negative 2 to the 5th cubed. Alright, negative 2 to the 5th. Now we're going to do 5 times 3/5, and we would just get negative 2 cubed. And then over here, if you do if you do the multiplication first, now you would have negative 2 to the 15th power, and then you're going to have the 5 on the outside. Okay, so negative 2 cubed is the same thing as negative 8. This one, it's kind of hard to see, but you could write this as negative 2 cubed to the 5th. I could rewrite it that way, and then the 5s would cancel out, and I would have negative 2 cubed, which is also equal to 8. Another way that I could have done this is I could have written it as the 5th root of negative 32 cubed. And this would be a little bit easier in radical form, because the 5th root of negative 32 is the same thing as the 5th root of negative 2 to the 5th, and then all of that cubed. Well, the 5th root of negative 2 to the 5th is negative 2, and then cubed, which is equal to negative 8. Okay, so that's the solution to this. Let's do another one. This time we're going to have variables in it. So if you remember, if you have an expression like this, ab raised to the m, that's the same thing as a to the m, b to the m. You distribute that exponent. So I'm going to do that now. This is the same thing as 18 to the negative 1/3 x to the 15 over 3, to the negative 15 over 3, which is equal to 18 to the negative 1/3. I'm just going to leave that for now, to the negative 1/3, and then x to the negative 15 over 3 is the same thing as x to the negative 5. So we've already got this term simplified. Now let's simplify this 18 to the negative 1/3. Are there any perfect cubes? If we were to rewrite 18 is the same thing as 2 times 3 squared. If I was to write that to the negative 1/3, it's not really going to help me, because there's nothing in here that's going to cancel out when I multiply out that 1/3 to the 18. So 18 to the negative 1/3, 18 to the negative 1/3 is already as simplified as it's going to get. I can write it in radical form if I want. I could write this as 1 over x to the 5th times the cube root of 18. Writing it as 1 over turns both of these into positive exponents, and then I wrote 18 in radical form. I could also write this. I could leave it as this. This is fine. But if I wanted the variables to be positive, I could write it as 18 to the 1/3 x to the 5th. These are all equivalent expressions. So that's it for this lesson. Just be able to go back and forth between radical form and exponential form. Actually, I'll go ahead and do this the other way. Let's write this as 1 over 18x to the 15 raised to the 1/3. That would be kind of the first step. And then I'm going to rewrite this in radical form, which would be the cube root of 18x to the 15. And you can simplify this if you want, and you'll see that you'll get the same thing that we had a second ago. The x to the 15 is going to come out, and you'll have x to the 5th, and the cube root of 18 does not simplify. All right, that's it for this lesson.